This slide shows the system pipeline used in my project. First, I used a dataset containing 2,562 images from 31 different classes. Next, all images went through the pre-processing stage where they were resized to 224 multiplied 224 pixels and normalized to ensure data consistency. After that, the processed images were fed into the testnet model using a transfer learning approach to improve model performance. Finally, the model generated the output, which is the classification result for each input image. This slide presents the final performance result of my model. The model achieved a training accuracy of 78.67 and the validation accuracy of 67.45%. This shows that the model was able to learn the training data reasonably well and achieve moderate performance on unseen data. In addition, the model obtained a weak F1 score of 0.6713, which indicate a balanced performance across the different classes in the dataset. The validation loss was 1.2447, showing that there is still room for improvement, but overall the model was able to perform the classification task with acceptable results. Overall, the result demonstrate that the testnet model with transfer learning was effective in classifying the image in our dataset. For this slide, I will explain the performance metric of my face recognition project. First, the model achieved an accuracy of 67.45%, which means it can correctly identify about 67 out of every 100 faces. This is considered a reasonable performance since the model needs to distinguish between 21 different classes of individuals. Next, the F1 score is 0.6713. The F1 score measures the balance between precision and recall. A value above 0.6 indicates that the model performs well and provides fairly consistent classification results. Looking at the best performing classes, the model achieved 100 accuracy for Amitabh Bachchan, followed by Roger Federer at 97%, Dwayne Johnson at 96%, and Boris Kudrow and Ellen DeGeneres at 88%. However, there are some challenging classes where the model had low accuracy. This include Margot Robbie at 25%, Akshay Kumar at 35%, and Anushka Sharma at 34%. This may be due to limited training image, variation in lighting condition, or similarity in facial feature with other classes. Overall, the model demonstrates satisfactory performance, but there is still room for improvement, especially in increasing accuracy for the more challenging classes. This slide outlines the technical requirement and deployment strategy for my system. For the system requirement, I need the minimum specification of an Intel i5 or i7 processor, 8GB RAM, 5GB storage, and Python with TensorFlow to support the modern manual for deployment option. I have three main approaches: executing it via the cloud, initializing edge device, or building it directly as a web application. This slide highlights the potential application of my system alongside the challenge and solution. I have identified 4 applications. This technology can be utilized in security system, autonomous internet, smart campus, and public safety. To ensure smooth implementation, I address key challenges like lighting variance and image quality through data augmentation and high resolution cameras, while managing computational costs and privacy concerns using model optimization and data encryption with consent. Was successful. Developed using DesNet 1-to-1 architecture for face recognition, the model was trained off a dataset containing 2,562 face images across 31 different celebrities and achieved a validation accuracy of 67.45% with a weight F1 score of 0.67 after 10 hours of training. Several challenges I faced during development, including limited dataset size, uneven distribution across classes, and variation in image quality. However, the system demonstrated reasonable capability in identify face and is ready for practical application. For future improvement, it is recommended to increase training approach, implement data augmentation, 5-tune DesNet layers, add more diverse subjects, and deploy the system as a real-time application. In conclusion, this face recognition system has been successful, is ready for deployment in real-world scenarios such as security system, internet tracking, and identify purpose.